The last problem that we're going to work with involves checking our domain and our range for our equations. The same process is going to apply, except for I've got to check my answers at the end. So this problem, ln of x plus 5 is equal to the ln of x minus 1 minus the ln of x plus 1. I can see on the right-hand side I'm subtracting two natural logs. And if I want to combine that into a single natural log, I can use the quotient property. The nice thing about that then is I'll have a single log on the right, a single log on the left. I can use my one-to-one property and then solve. So here, ln of x plus 5. And on the right-hand side, I'm going to use the quotient property, which means I can rewrite both of those logs as a single log. Now that I've got a single log on each side, I can use the one-to-one property that says x plus 5 is equal to x minus 1, x plus 1, the two quantities that we have inside the logs. And now I can solve for x. Start by multiplying both sides by x plus 1. My right-hand side, I can FOIL that out. And then we can move our x minus 1 quantities over. So now I've got x squared plus 5x plus 6. I can factor that down to be x plus 2 and x plus 3. So x is equal to negative 2 and x equals negative 3. Now normally at this point we would say box our answers and be done, but we need to check our work. If I do the ln of x plus 5 equals the ln of x minus 1 minus the ln of x plus 1, let's simplify this out. Start with x equaling negative 2 is what we're going to check. So negative 2 plus 5 is equal to the ln of negative 2 minus 1 minus the ln of negative 2 plus 1. The left-hand side, I've got the ln of 3. On the right-hand side, ln of negative 3 minus the ln of negative 1. I then say, hey, I can use my quotient property here. Ln of negative 3 over negative 1. And I can see that the ln of 3 is equal to the ln of 3. However, I've got one small issue. And the one small issue is this step right here. These two values actually do not exist. I cannot take the natural log, or a log for that matter, of a negative number. The domain for a logarithmic function goes from 0 to infinity. So I cannot include a negative number. So even though this works out mathematically, there is no solution to this equation. So here x equals negative 2, x equals negative 3. Neither of these are going to be solutions. There's going to be no solution. And I can see that because if I were to plug negative 2 back into my original expression, here negative 2 plus 5 is the ln of a positive 3. Perfectly fine. But as soon as I go here, negative 2 minus 1, I'm taking the natural log of a negative number. That cannot happen. So I know at that point negative 2 doesn't work. Same thing with negative 3. Over here, negative 3 plus 5 is a positive 2. Perfectly fine. But at this step, when I plug in a negative 3, I get the natural log of negative 4. Once again, does not exist.